Hi again. Um, Lately we've been talking about fish populations, and so I want to talk about that a little bit. In this first part, I want to talk a little bit about fish population density, number of organisms per unit area, number of fish per hectare, number of fish per acre. This is the first important number. We're always interested in how many fish we have in our lake. Uh, often we use CPUE, catch per unit of effort, the number of fish per hour of electrofishing, the number of fish per net night. That's the most common way. It's the quickest. It's the easiest. It does allow us to look at trends over time. We've got some problems because, first off, standardization. My electrofishing boat might not shock the same as yours, so fish per hour might be a little bit different there. Also, how do you compare an hour of electrofishing to an hour of gill netting? Those problems have always been around. It still is a very useful way to get an estimate of the number of organisms and certainly to track the number of different fish species in your lake or your river over time. Often, though, we want an actual estimate of the number of organisms in our population. And there are several different ways that we can go out and count the number of organisms. For fish, the easiest is to drain the lake and count them. Obviously not a good idea. Cove rotenone has been used, where you block off coves in the lake, rotenone everything inside the cove. They used to actually advertise this. You had these big studies. This was done down south quite a bit. People would come out and they would allow the citizens to come and pick up and take home the fish after they counted them. Don't let you do that anymore. Rotenone's really non-toxic to humans, but still, they don't really do that a whole heck of a lot. The depletion method we talk about in your PowerPoint, the details are in there. It's essentially seining the pond or putting a standard effort into a body of water, pulling the fish out, counting them, and then holding them, so depleting the population. And as you do that, your catch per unit of effort goes down. You can use the total catch and the catch per unit of effort to extrapolate and estimate the number of fish that are in the population. This is very good for something small like farm ponds. But the best way, the most common way to get the number of organisms is through mark recapture. And that's what we want to talk about. This is used throughout a lot of ecology. There's a lot of science behind it. Excuse me, I'm trying to stay hydrated. So the first thing we need to talk about is how are we going to mark fish. And there's lots of ways to mark fish, and we go over several different ways in your book. The first is, check the notes here. The fin clip is something we use a lot. Basically just cut the fin and it will regenerate, but when it regenerates, the rays aren't well lined up. And so a trained eye can notice a regenerated fin. Of course, if you catch the fish soon enough before the fin has had time to regenerate, you can see where the fin has been clipped. So this is very quick. If you do it on the right fins and the right way, it doesn't hurt the fish. It certainly doesn't hurt the fish, and it doesn't interfere with their swimming behavior, but it does take a little experience to recognize it. Another common mark is an external tag. Lots of different external tags. The most common is probably the Floyd tag or the spaghetti tag or the T-bar tag, where you take a tagging gun and you just put the little tag and it sticks out next to the dorsal fin. The trick with the T-bar tag is that it's got to get down in there amongst those pterygophores. That's the bone and cartilage that attaches to the dorsal fin rays and the erector muscles and allows the fish to erect their dorsal fin or lay their dorsal fin back. So the anchor of that T-bar's got to get down in those pterygophores, and that's what's going to hold it in there. So that's why when we tag them, we twist it, and then when you have the tag in there, you give it a twist and a little yank, and that helps to seat that anchor amongst the pterygophores. Other common tags are internal tags, and I described several of those in there. One you may be familiar with is the pit tag, which is like a grain of rice. If you're dog or your cat has ever been tagged by the vet, they're using a pit tag, the identification tag that they put in the back of the neck of dogs, or we put it in the abdomen or different places on the fish. You run a scanner over a fish, it's got a pit tag. The scanner will recognize the unique identification number from that pit tag, so you can get individual identifications on fish, which is very useful. You can also set up a big array, and if the fish swim through the array or near the array, then you can identify individual fish. Another way to mark fish is using OTC, or Oxytetracycline. This is an antibiotic. You dissolve it in the water, you let the fish swim in it for a little bit, they take it up, it gets deposited in their otoliths and in their rays. It's more or less a permanent mark. Then later on, if you get the otolith or the ray from that fish and you put it under a microscope and illuminate it with the proper wavelength of light, that OTC band is going to glow, a beautiful golden ring that's very obvious. So this is a great way to batch mark fish. A lot of fish, or if you've got small fish that are too small to tag in any other way, this is a great way to mark small fish. You can release them. Over the years, as you catch adult fish, you can find those ones that have your mark, and then you can validate annuli, and you have known age fish. You can double mark fish. You can mark them with OTC, hold them in clean water for a few days or a week or two, put them in the OTC again. They'll have two bands. So it's a very useful technique. Just take some specialized equipment and some experience to recognize it. The last way that I mentioned for marking fish is probably the wave of the future, which is DNA marks. As we develop more microsatellite markers and other type of DNA markers for the fish, we'll probably just take scales off the fish, and as you capture more fish, you take scales, run the DNA, and you'll be able to recognize individual fish and use that as a mark. We're not there yet, but we're getting there. So that's several different ways that you can mark a fish. In the next part, I'm going to talk about how you can use those marks in those recaptured fish to estimate the number of fish in your population.